8.6 trigonometry. Today we're going to solve right triangles. This is the first day that we are working with inverse trig ratios. So the one thing we want to remember is to use trigonometry, we have to be working with the right triangle. Today we're going to talk about solving a right triangle. And that's when we find the measures of all of its sides and angles. So there's 3 sides we need to know and 3 angles we need to know. So if we slide down here, this is the type of problem that we did last night where we have an angle, we have a side, and we can calculate what the other sides are. So as long as we have a right triangle, we could use opposite over hypotenuse, we could use adjacent over hypotenuse, and we could solve for the missing sides. We could calculate the missing angle by subtracting from 180. Or knowing that the acute angles of a right triangle are complementary, we could figure out what this angle is. But what if we're in a situation like this triangle, where we have 2 sides, but we don't have the third side? I can't use trigonometry to solve for that because I don't have an angle value. You can't use the 90. So we would use Pythagorean theorem. Hypotenuse squared equals leg squared plus leg squared. And that would give us our third side. But then how do I figure out these angle values? What's the angle, the acute angles of this triangle? Well, that's where we come into this inverse trigonometric ratio. Inverse trigonometric ratios are used to calculate the angles. We use inverse trig to calculate what the angle value is. All the vocab's the same. The calculation might be written a teeny bit differently, but it's all the same: opposite and adjacent and hypotenuse. So we can do tangent inverse, sine inverse, and cosine inverse. So let's come on down here to this first one. We're not given a figure, we're just given the formula, the equation essentially. So sine of an angle equals 0.76. You could say that you have a right triangle with an angle A, and if the opposite over hypotenuse is going to be 0.76, there's an infinite number of measurements those could be. But we could simply just make it 76 over 100. And if you were to do opposite over hypotenuse, you would get 0.76. The question is, what angle does this have to be? So if you look at sine and you look at our triangle that we have drawn here, we know the opposite and we know the hypotenuse. So of course we're using sine. So we have sine of A that equals 0.76. But what we want to solve for is the A value. The A value is going to be traded with our side calculation. We're going to switch those. So we're going to write sine inverse of 0.76. We are calculating what the angle is using the side measurements. So sine inverse of 0.76 is going to equal the measurement of angle A. So that's going to help us determine this angle value. So looking at your calculator, if you zoom in closely, you'll see that sine, right above it, we have sine inverse. The cosine button has cosine inverse. And the tangent button has tangent inverse. And those inverses are how we calculate for the missing angle. You use the inverse to calculate for the angle. I can't say that enough. So we're using sine inverse. So I'm going to hit the second button. Then I'm going to hit the sine button. And that should give me sine inverse. So we have the little -1 that's involved. And we're doing 0.76. We hit enter. And that gives us a 49.46 degree angle. Now we do the same thing over here with the cosine of b that equals 0.17. We are going to switch to get the b by itself. We're going to have to use cosine inverse, and we use our parenthesis of 0.17, and that's going to equal the measurement of angle B. We're solving for the angle. For us to get the B by itself, we've got to use cosine inverse. Essentially, we're switching the angle with the side measurements. And we just go to our calculator, and we hit the second button, and then we hit the cosine button. So that gives us cosine inverse of 0.17, and that gives us 80.21. Those are degrees, and that's the measurement of angle B. So you can calculate the angle of any right triangle. So at home, you probably have right triangles somewhere in your house, and you can calculate what that angle would be. Tangent of A. Well, we're going to switch the A and the side measurements. The side measurements reduce down to 0.8. We're going to switch those so we can have A by itself. To do that, we have to use tangent inverse of 0.8. And that is equaling the measurement of angle A. So very simply, we go to our calculator, we hit second tangent of 0.8, and that gives us the 3866. 3866. And that's the measurement of angle A. So we can solve for an angle if we're given sides of a right triangle. So with our second example, this is where we are solving a right triangle. Let's come on down and take a look at what solving means. To solve a right triangle is to find the measures of all of its sides and angles. You need to know all three sides and all three angles. Well, I know two of the sides already, so I'm going to be able to calculate what the other side is. So that's AC. I know what one of the angles is, 90. Of course, you have to have a 90. But I don't know what the other two angles are. The measurement of angle A or the measurement of angle C. So those are the three additional values I need to calculate. I currently have 3 bits of information, and I need to find 3 other bits of information. That'll give me 3 angles and 3 sides. So what can we find first? Well, if I know 2 sides of a right triangle, I can find the third side by using Pythagorean theorem. And that's hypotenuse squared equals leg squared plus leg squared. So what goes in those spots? How are we going to set this up? The hypotenuse is always across from the 90 degrees. So that's AC. You could put an X there if you wish, or I would suggest just call that AC. The legs are always the perpendicular sides. So that would be 16 squared and 20 squared. It really wouldn't matter which order you put those in. You could put the 20 first if you want, with the 16 and the 20. But neither of those numbers could be over here under the hypotenuse. Remember, hypotenuse has to be across from the 90. So AC squared equals 256 plus 400. So that is 656. 256 plus 400 gives us 656. So I'm going to take the square root of both sides, and that's going to give me an approximate value. We have 16 squared and we have 20 squared. That gave me my 656. Then when I took the square root of 656, I'm going to have 25.61. So this length was 25.61. That was AC. So remember that a hypotenuse has to be the longest side. So if you get a number that's really small, something was wrong with the calculation. It has to be longer than the legs. Now, also, the legs added together have to add up to be longer than the hypotenuse. So this hypotenuse could not be 656 because these two lengths would never add up to it. They only add up to 36. So this length has to be less than 36, which in our calculation it was. So this seems reasonable. It's longer than the two legs and it's shorter than the sum of the two sides. Now, how are we going to figure out angle A? Looking at A, we know the opposite side and we know the adjacent side. So thinking about SOHCAHTOA, we're going to use opposite and adjacent. That's tangent. So I'm going to say tangent of A equals the opposite over the adjacent. 16 over 20. Look where the variable's at. My variable is the angle, but I want to get the angle by itself. So I'm going to switch these two. I'm going to switch the side measurements with the angle, just like we did earlier. To switch those, I have to use tangent inverse. And that equals the measurement of angle A. So we can easily hit second tangent, 16 divided by 20, and that gives us our 38/66. That's our measurement of angle A. We could also write that in a triangle, somewhat small, 38, 66. Now you can see, because you're writing the measurements on your triangle, we're missing one piece of information. We're missing angle C. How can we calculate angle C? You've got a few choices. You know that the triangles add up to 180. You could use that. Or you could use opposite over adjacent. Opposite of angle C would be this one, and adjacent to angle C would be that one. You could use that and do inverse again. But let's just use the 180 rule. We know that 90 degrees plus 3866 plus the measurement of angle C has to add up to 180. These two added together are going to be 128.66 plus the measurement of angle C equals 180. And when I subtract 128.66 from 180, I get 51.34. So angle C is 51.34. That makes all three angles add up to 180. And now I have all three side measurements and all three angle measurements. We solved the right triangle. Let's try that again on this one. What do you see? What do we have to solve for? What don't we already know? You got to look at it. I have angle A as 23 degrees. I don't know angle B. So the measurement of angle B is what I'm calculating. I know the hypotenuse, because that's across from the 90, but I don't know the other two measurements. So I'm going to be looking for AC, and I'm also going to be looking for BC. That will give me all three sides and all three angles. So to find the measurement of angle B, I know that 23 plus the measurement of angle B plus 90 equals 180. 90 and 23 add up to be 113. So I'm going to subtract my 113. And I get 67. So angle B is 67. And those are degrees, so we put our little circle up in the corner. Degree symbol. Next, we're solving for AC. Well, what side would we call AC? It depends which angle we're considering our focus to be from. From our perspective of the 23, this is the adjacent side. And the 40 is the hypotenuse. So let's use cosine of 23 to equal the adjacent over the hypotenuse. We place the cosine of 23 over 1. we cross multiply, so that's 40 times the cosine of 23. $40 times the cosine of 23 gives us 3682. Now be careful, you cannot say cosine of 23 times 40. You can't say that, you get a completely different result. So if you were to do cosine first, you would need to be sure to close the parentheses and say times 40, and then you'll get that 3682. So you do need to know how to type it into your calculator. It is good to practice typing this in so you're aware of how that works. 3682. That was AC. This is why we don't want to just call every missing side X, so we know exactly what we're trying to solve for. The other missing side would be opposite over hypotenuse. So now we're going to do sine of 23 equals BC over AB, which is 40. And we multiply by the 40. Now we're doing the same type of calculation, but we're using the sine because we're solving for the other side. So this is 40 times the sine of 23. And that gives us 1563. We would round up to 63. So now we have solved and we know all three angles and all three sides. So that's solving when you know all three angles and all three sides. Here's a word question. You're building a track for a model train. You want the track to incline from the first level to the second level. The second level is 4 inches higher. You have a 96-inch run for your train to be able to climb up. You need to be sure that the angle is less than 3 degrees or your train won't have the power to get up. So we're going to work with the opposite and the adjacent. So we're talking about tangent of our angle, and that should equal the opposite over the adjacent, which is 4 over 96. What is the angle that is required to climb? Now, I want to solve for the angle. That means I have to switch these two. I need the x by itself. So that means I have to use tangent inverse of 4 over 96 to equal the measurement of angle x, or you could call it x degrees. So second tangent gives us tangent inverse of 4 divided by 96, and that angle is 2.39. And yes, that is less than 3 degrees. So on the flip side, we're going to be going up a driveway which is 25 meters long. It climbs 4 meters. So we want to figure out the angle of the driveway. So this is the opposite, and this is the hypotenuse. So we're going to use sine of our driveway. That equals opposite over hypotenuse. We're going to switch the sine and the x and the sides. So we have to use sine inverse to equal the measurement of angle x. So to do that, that's second sine of 4 over 25, and that's 9.21. So the measurement of angle X would be 9.21 degrees. And our last question, down here at the bottom, we have a stair steps, and they rise up 18 inches, and they have a tread of 32. So we can treat that right here. We're trying to find theta. That's what this stands for, is theta. And the height is 18, and the tread is 32. So we're going to use tangent of theta. That's just a variable that stands for an angle. So we're going to switch what theta and the side measurements are. So tangent inverse of 18 over 32, that's going to equal our theta. So second, and then tangent of 18 divided by 32, and that's 29.36. Theta is a variable that stands for an angle. You'll see that all throughout mathematics.